The speed of light is often considered the ultimate universal speed limit, an untouchable barrier that nothing can exceed. But is that really true? Could something somewhere travel faster than light? Welcome to Großdenken, everyone. In today's video, we'll explore the science of light speed, why it's such a fundamental limit, and whether certain phenomena in the universe might actually break this cosmic speed barrier. Let's dive in. First, let's talk about light. The speed of light in a vacuum is roughly 299,792 kilometers per second. That's about 186,000 miles per second. At this speed, light could travel around the Earth 7.5 times in a single second. But why is this speed so significant? The speed of light, often denoted as c, is a fundamental constant in Einstein's theory of relativity, which completely changed our understanding of space and time. Here's why it matters. Relativity tells us that nothing with mass can reach or exceed the speed of light. As an object with mass approaches the speed of light, its energy requirements grow infinitely large. Light speed is the maximum speed at which information or causality can travel. This means no signal, no particle, and no force can communicate faster than c. In other words, the speed of light isn't just a property of light, it's woven into the very fabric of the universe itself. Einstein's special theory of relativity, published in 1905, explains why the speed of light is such a hard boundary. Here's how it works. As an object moves faster, its relativistic mass increases. To accelerate something closer to the speed of light, you'd need more and more energy. At the speed of light, the energy required becomes infinite, an impossibility. This is why particles with mass, like humans or spaceships, cannot reach light speed. Light particles, or photons, can move at this speed because they're massless. Now, let's address the big question: can anything travel faster than light? While nothing with mass can directly break the speed of light barrier, there are some fascinating phenomena that might seem to cheat this rule. Let's explore a few of them. First, we have tachyons, hypothetical particles proposed in the 1960s. Tachyons are theorized to always move faster than light. But there's a catch: tachyons would violate causality, meaning they could theoretically allow effects to happen before their causes. There's no experimental evidence for tachyons, and many physicists doubt they exist because they conflict with relativity. For now, tachyons remain a purely theoretical idea. Next, we have quantum entanglement, a phenomenon famously described by Einstein as spooky action at a distance. Here's what happens. When two particles become entangled, their states are linked, no matter how far apart they are. If you measure one particle, the other's state is instantly determined, even if they're light years apart. But this doesn't actually violate relativity. No usable information is traveling between the particles faster than light. Quantum entanglement is fascinating, but it doesn't allow us to send signals or objects faster than light. One example of something faster than light is cosmic inflation, which occurred just after the Big Bang. During the first fraction of a second, the universe expanded exponentially, much faster than the speed of light. But this doesn't break relativity because it wasn't objects moving through space faster than light. Instead, space itself was expanding, carrying galaxies with it. This is a key distinction. Relativity limits the speed of objects in space, but not the expansion of space itself. Lastly, we have Cherenkov radiation, often seen as a glowing blue light in nuclear reactors. Here's how it happens. In a medium like water or glass, light slows down. Certain particles, like electrons, can travel faster than light's reduced speed in that medium. It's important to note that these particles aren't breaking the universal speed limit. They're just exceeding light speed relative to the medium they're in. While these examples are fascinating, true faster-than-light travel, like in science fiction, faces enormous challenges. Here's why. Energy requirements. Accelerating any object with mass to light speed would require infinite energy. Time dilation. At near light speeds, time slows down dramatically for the traveler, making meaningful communication nearly impossible. Causality violations. Breaking the speed of light could lead to paradoxes, like traveling backward in time. These challenges make faster-than-light travel highly unlikely, at least with our current understanding of physics. That said, scientists have proposed ways to bypass the speed of light limit using concepts like wormholes or warp drives. Wormholes. These are shortcuts through space-time connecting two distant points. While theoretically possible under Einstein's equations, wormholes would require exotic matter with negative energy to keep them stable, something we've never observed. Warp drives. Inspired by science fiction, a warp drive would compress space in front of a spaceship and expand it behind, allowing the ship to travel faster than light without technically breaking relativity. The most famous example is the Alcubierre drive, but it would require enormous amounts of negative energy, making it purely theoretical for now. These ideas are exciting, but they remain in the realm of speculation until we better understand the laws of physics. So can something travel faster than the speed of light? According to our current understanding of physics, nothing with mass can exceed this universal limit. However, the universe is full of strange phenomena, like cosmic inflation and quantum entanglement, that challenge our intuition. While science fiction often dreams of warp drives and faster-than-light travel, the reality is that these ideas are still far from achievable. But the pursuit of these possibilities continues to drive human curiosity and innovation. What do you think? Will humanity ever find a way to break the light speed barrier? Let me know in the comments below. And don't forget to like, subscribe, and hit the bell icon for more videos exploring the mysteries of the universe. Until next time, keep questioning and keep exploring. The answers may be closer than you think.